all of you get the sheets? Any leftovers? Any leftovers? Okay, no? There are one or two people actually getting there. Sorry? When you hear actually when they distribute it. How many of you didn't get? Not actually, no, we are more than 150. I brought 140 plus actually, I thought around 130, but still actually my calculation is wrong. But these things will be posted anyway on Blackboard. So, meanwhile actually if you don't have access to the sheets that are circulated, please do follow on the overhead project. So the questions are very simple actually. These questions are basically taken from the course textbook. When you look at the first one, first problem is very simple. The discussion that we have, by using that discussion you can always solve most of these are all the problems. Assume that you are considering selecting assets from among the following 4 candidates. So you have 4 assets. Okay. These are basically created problems, not from the actual data. Don't worry about the market condition, all sort of things. For these 3 assets, you have the probabilities and the returns. 4th asset is a bit different. This is not depending on the market conditions. Okay, so it is depending on something else, that is rainfall. And depends on the event. If you have plentiful rainfall, actually then the returns are 16, average rainfall 12, so on and so forth. This is basically a description of those 4 assets. So what you should grab from these 4 tables is basically what are the returns. Returns are not deterministic, they are non-deterministic, and they have their own probabilities. The first part is straightforward, all of you can do. Solve for the expected return and standard deviation of return for each separate investment. So I think that is a simple one. I just show for the asset 1. They're basically asking you to find the expected return of the first asset, and we have already we understood that is the expected value, half times 12, 1/4 times 8, so you get the expected return. And the variance of R1 is equivalent to expected value of R1 minus R1 bar square. What is the expected value here? You have 4 plus 3. How much? 12. And you can find the variance. So variance is not an issue here. So you have the probability 1/4, and that is 16 minus 12 whole square plus So the first part is basically testing whether you know the definition of expected value and variance. As a sort of warm up. And you can repeat the same for the rest of the problems. Okay? I'm not going to embarrass you by keep explaining expectations and standard deviation. Second one. Solve the correlation coefficient covariance between each pair of investments. Each pair of investments. How to find the correlation coefficient? If I take asset 1, asset 2, okay, how to find the sigma 1, 2, let us say variance, covariance is sigma 1, 2 whole square, that is equivalent to expected value of R1 minus R1 bar times R2 minus R2 bar. Is that correct? That's the covariance. So, covariance of, I can write this as covariance of asset 1 and asset 2 is equivalent to, we just remember the probabilities and the associated, the probability is 1 upon 4 and R1 minus R1 bar, how much is that? The first one, 16 minus R1 bar, how much? Let me write 16 minus 12, that is the first instant. And similarly, you have 4 minus, did you calculate the expected value of the second? 6, okay. Plus, can you repeat the remaining things? I just calculated the first one. The next one is basically covariance. So the next probability is half times, 12 minus 12, 6 minus 6, that's 0, plus 1 upon 4, 8 minus 12, 8 minus, okay. So it's basically, you get the covariance. And correlation, you know how to do that. Okay. Divide with variance of the first one, the standard deviation of the first one, and standard deviation of the second one. If you can do that, you get the required. What's the answer here? Covariance of asset 1 and asset 2. We have calculated. Okay. So I think you can do all these things similarly, but there is a tricky case. How many? Sorry. Yeah, I'm about to ask the same one. Who asked that here? So, okay, yeah. The tricky one is covariance of asset 1 with asset 4. Anybody? So, if you look at the given assets, for everything it looks fine, But asset 1 and asset 4, or for that matter, asset 2 and asset 4, asset 3 and asset 4. How to find the covariance? Because in the previous pairs actually you have the luxury of using the same probability. Okay? In this case actually you have different probabilities. Any guess? Read the question carefully. If you look at the sentence, assume that there is no relation between the amount of rainfall and the condition of the stock market. That means, so the answer is 0. That's it. And yeah, once you know the covariance, you are in a position to find the correlation coefficient by dividing with the standard deviations. Yeah. So that is very simple exercise. Part C. Part C is solve for the expected return and variance of each of the portfolios shown in the following. Okay? Expected return and variance of the portfolios. See this here. So you have 4 assets. Okay, if you know how to do at least one portfolio, then actually you can repeat all the portfolios. The first portfolio, there are how many portfolios? There are many portfolios until I. Let us look at the first portfolio. Portfolio A. What sort of combination portfolio A is going to consider? 50% of the wealth is assigned to asset 1. The other 50% is on asset 2. Okay? I am talking about portfolio A. So according to that, %, asset 1 and the remaining 50% on asset 2. So you need to find the expected return of the portfolio. So expected return of the portfolio is equivalent to x1 expected of first asset, x2. This is basically the formula that we have in our previous discussion. Okay. And x1 equals to so yeah, 0.5 or half. Okay. Otherwise you may get. And expected value of R1 first assets return 12. And the remaining 50% half, and R2 6. So this equals to 9. So this is the expected return from the portfolio. Well, okay, if you change the weights of the portfolio, then obviously you get different returns for the other. That is entirely different portfolio. Okay. And you should also find the variance. So variance of the portfolio is equivalent to, if you remember, x1 square sigma 1 square, x2 square sigma 2 square plus 2 x1 x2 sigma 1 2. Okay. we have all these values. X1 square, we know the portfolio weights, that is half square. Sigma 1 square, the variance of the first portfolio. What's the value? Variance of the first portfolio? 8. I'm just using 8. Because I don't know whether I have solved this problem or not, but let me see that. Variance of the The first one is 8. Second one is half square 2 plus 2 times half times half. And covariance, has anybody calculated sigma 1, 2? Minus? We already done here. Minus 4. So this is 2 plus half minus 2, that equals to okay. So this is the variance of the first portfolio. Oops. Sorry. So easy. So what? What happened? Well, you may not find questions like, find the expected value of the individual asset or the variance of the individual asset, but in the final exam you would find problems like this, at least something related to variance of the portfolio, expectation of the portfolio, how to get the required variance by selecting the appropriate x1, x2 values, these kinds of problems. Very much similar to what we have done just now. Any questions here? So yeah, you can repeat the same for all the portfolios, and I don't see any problem with the remaining portfolios. The only thing is it takes time, and yeah, you do that as homework. I'm not asking you to submit, okay? That would definitely help you for the final exam. Or at least before coming to the final exam, you should solve all these problems, okay? Otherwise you will regret. Okay, you can take actually Christmas break, you can take Easter break. I'm just asking you to solve all these problems at least once before coming to the final exam.
他就是说我们做完以后在考试还有
Yeah. So now part B is basically plotting the original assets on each of the portfolios that you created from part C on a return on standard deviation space. What does that mean? For each and every portfolio, you have a pair of numbers, expected return and variance. And each asset has a pair of numbers, that is also returns and variance. For part D, what we need to do is, question 1, part D, you need to plot these things. Usually we do consider sigma as horizontal one, and this is the RP bar, this is the portfolio's return. And each and every asset would give you two numbers, one for sigma and the other one for return. Okay? what you need to do for part D is basically locating those points on this two-dimensional graph, nothing else. That's it. So you can see the graphical nature of the portfolio while you are changing the weights. Okay. By slightly changing the weights, sigma and R value, the expected returns of the portfolio would be changed. So this part D is about verifying how these things are basically changed. And I don't see any problem in plotting those points on the graph sheet. Okay. Yeah, this must be homework because I cannot do these calculations, and usually you don't expect these sort of numbers in the final exam. I don't embarrass you by just giving fractional numbers. I do believe in integers, I just give only integers, okay? So, but again, as long as you are comfortable with these decimal numbers, so you have to repeat the same calculations that we have done for the previous problem. Okay. Only thing is, they are basically asking you to construct the portfolio according to the given weights. First portfolio, half and half. Second portfolio, half and half of AB. Second portfolio, half A and C. The third portfolio, equal weight on these three assets. So this is very much the same as what we have done. Okay? Do you see any problem? I don't see. So you should also agree with me. Okay. So the last one is third one. There are a few more questions very much on these three problems. I will post those remaining questions. As I mentioned, please solve these problems, okay? At least once. Twice is definitely good. Okay, so the next one is, third one. Assume that the average variance of return of an individual security is 50 and that the average covariance is 10. What is the expected variance of an equally weighted portfolio of 5, 10, 20 and 100 securities? Sorry, I forgot the formula. Yeah. Let me use this. So, how many of you understand the third problem? Assume that the average variance of the individual assets in the security, individual security is 50. So, average variance is equivalent to 50. You can repeat the same actually with covariance on the end. And how many securities you have in portfolio? There are different cases. In case 1, you have 5. Case 2, you have 10. And you have 5 cases. Case 5, you have 100 securities. Okay. The question is the expected variance of the portfolio. Okay. So if you look back your lecture notes, we just discussed that when you are considering the equal weights, then the variance of the portfolio is equivalent to 1 divided by n sigma the average variance of the individual assets. But here, remember that we assume that the assets are independent while deriving the formula. If assets are not independent, then this formula would take the following form. This will be there, but in addition to that, you have n minus 1 upon n sigma bar jk, where this is representing the average covariance and this is average variance. No, I should shout actually, otherwise. Okay. So this is the formula when you assume they are independent, but in this case that is not the case. When they are depending on each other, this covariance term is not going to be 0. It will be there. And I can write this as, now I have all the data. Case 1, how many assets I have? 5. And what is the average variance? 50, they gave. 5 minus 1 by 5. And average covariance also given to me, that is 10. And this will give you the variance of the portfolio when you have n assets with average variance and covariance as 50 and 10. It's a simple substitution. By the way, I prefer to give the required formula in the final exam. Unless that is very common formula, I don't give, but actually in addition to the questions, I don't give answers, but I will definitely provide you with the important formula that you can use. Otherwise, memorizing these things will be ridiculous. But you should understand the concepts. I'm not going to test your memory. Okay. So it's very simple, straightforward exercise. So hope you are comfortable now, at least how one can estimate the expected value of the portfolio, expected returns of the portfolio, and the variance of the portfolio. Whether we have 2 assets, 3 assets, 100 assets, doesn't matter. Okay? You can use the same logic and do the analysis. So far actually we just understand how to create a portfolio. Well, anybody can create a portfolio. What do we mean by portfolio? We need more than one asset, and you should assign some of your wealth on the individual assets in the portfolio. And the technical stuff we discussed is basically the underlying return and variance of the given portfolio. That's good. But now the important step, the next step in portfolio theory is basically how to find the feasible portfolios for the given situation. Okay. There are 10 different assets given to me. Then actually I'm just wondering how many portfolios I can create. Okay. At the moment, if somebody gives you individual portfolio, you know how to calculate their return and variance. Now the next level question is, if somebody gives you the assets, are you in a position to identify all the relevant portfolios for the given set of assets or not? That is the next step we are going to discuss. Okay? Before that, any questions? No, actually I have one extra copy for that person left. Anybody? I can give this copy. Please pass. Okay. Yeah, I think the next topic is a bit lengthy, so I don't think actually we could do any further tutorials until I finish that. So perhaps next tutorial might be, anyway I will distribute that, but next tutorial questions would be in the next class. But until then actually sit back, relax and listen to me carefully. If you have any questions, let me know. Okay. So, the question is, now, let us start with a simple example. What happens is, if we just keep looking at the variables, perhaps some of you might miss the underlying equation. So what I do is, while using the variables, I simultaneously assign some numerical values so that actually you can see things in a sort of simplistic manner. Otherwise, you may end up with, sort of hundreds of terms in a complicated manner. So I try to simplify them. The question that we are going to answer in the next 1 hour is the following. How many portfolios can be created from the given set of assets? Well, the answer is ridiculously simple. Anybody can say that actually that is infinite. Okay? The second one is, can you identify all the returns and variances of those portfolios? That is not that trivial. The third question is, can you find the geometric representation of all the portfolios? Returns and variances. So, this question has 3 parts. I start with a simple example. If we know how to do that for 2, you can do that for n, as long as n is finite. In reality, we have only finite number of assets. So, I just consider 2 assets. Two different stocks. I just name them as C and S. C for some, I forgot the stock name actually. Starts with C, and another stock starts with S. So, doesn't matter. And I also consider expected returns and standard deviation. The simplest case, I have 14% returns 8% returns from the other stock, and the standard deviation is 6%, 3%. Remember that we are not considering the probabilities here. We summarize the things, and we are from now onwards we are looking at the things like expectation and the variance. Okay? So returns from the portfolio, easy. So this is weight that you have assigned to the stock C and the expected returns from stock C plus excess, weight that you have assigned to stock S and the expected returns from the. So this implies your expected returns is equivalent to RC value is 14 XC, because I would like to simplify the things by giving numerical values, otherwise everywhere you find some variables. Plus expected returns from stock S is 8 XS. And the variance of the portfolio that we are going to create, just use the same formula, but the only thing is I just, instead of writing 1 and 2, just change C and S. C is my first stock, S is my second stock. X square sigma S square. Sorry, instead of doing that, actually I would like to simplify this further. XC square sigma C square. XS can be written as 1 minus XS, XC, sorry, because my assumption is XC plus XS equals to 1, and both XC and XS are less than or equivalent to 1 and greater than or equivalent to 0. Sigma S square 2XC 1 minus XC sigma C sigma S rho CS. Just the same formula, portfolio formula, I just written here. Okay, nothing new here, but from now onwards we can get something new. Usually rho CS would be somewhere between -1 and +1. Rho C value belongs to the set of -1 and +1. So any value would be given for rho CS. That is basically the correlation coefficient. Okay. Let us look at some of the extreme examples or extreme cases. Case 1, I do consider rho CS equals to +1. Okay. If I write the rho CS, then how the portfolio variance is affected. That is, instead of rho CS, I just replace this with +1, nothing else. So I have x is C square sigma C square plus 1 minus XC whole square sigma S square and sigma C sigma S. Okay. Okay, so if we simplify this, how to simplify this? Can anybody see any sort of formula, a plus b whole square kind of thing? A, b, So I can always write this as xc sigma c plus 1 minus xc sigma s whole square. Okay? Can we write that? We can. So a simple question actually to all of you. Y square equals to x square. Y equals to? Who said plus or minus? Absolute value. Okay. Any other option? Plus or minus x is the right answer. Okay? Because, for example, if you take x equals to plus or minus, you get the same positive value. Y square is always positive. That positiveness can be obtained by substituting plus value or minus value because it has square. Okay? So, hope you understand. Okay? That is plus or minus. This example can be used here. Sigma p square. It's something like y square equals to something square x square. Okay? So sigma p equals to xc sigma c plus 1 minus xc sigma s, or that could be minus of xc sigma c plus 1 minus xc sigma s. Okay? So this could, according to this argument, this could be this or this. Mathematically that is fine, but there is an issue here. In reality, standard deviation, have you ever seen negative standard deviation? No, because first we calculate variance and after that we find the square root. So, but the thing is, since we have the following assumption, xc plus xs equals to 1, 1 minus xc is always positive. Agreed? Because x is less than 1, 1 minus xc must be a positive value. And here xc is also positive value. And you know that sigma c and sigma s are already positive. So that means you get positive. But the second option would always give you negative. So that means it is not reality. Mathematically it's fine, but it is not representing the reality. So when case 1 rho cs equals to 1, the sigma p is equivalent to xc sigma c plus 1 minus xc sigma s. So let us use the returns that we have calculated. If you just go to that, Rp bar equals to this one. I just rewrite here so that actually you don't miss the Rp bar equals to 14xc plus 8 times 1 minus xc. Here, hope you remember the very first slide. I think if I show that, you may get confused. Let me write down the next step and I go back to this so you can get the overall unified picture. So you have two equations, first one and second one. The first one is representing the variance of the portfolio. The second one is representing variance of the returns of the portfolio. Now the ultimate aim, one of the important questions in the beginning that we mentioned are, what is the geometrical representation of the variance and returns of the portfolio? So that means I would like to plot a graph for the R bar, RP bar. Okay. By looking at these two equations, I would like to plot the graph so that actually I can see all the points. How can I get the point? By substituting the appropriate value for xc. If I substitute xc equals to some value, then obviously I get the corresponding sigma p. So let me write down these things. Sigma c and sigma s are given. So actually sigma p equals to xc times, what is sigma c that we noted down? Sigma c is 6 in our numerical example. Sigma s is 3. Okay. So 6xc plus 3 times 1 minus xc. So this is your modified first equation, and you have the second equation. By looking at these two values, you should plot the graph. But we all can plot the graph as long as the mathematical formula is in terms of only sigma p and r bar. Hope you are with me. This is the most important step. So if you do not understand, please let me know. Okay? What I am saying is, in the simple case, you have x and y. If I give you y equals to 2x plus 1, you know how to plot the graph. So that means the equation that I am giving to you should have y and x terms only. Then you are so comfortable to plot the graph. Okay? But come back to the situation that we have. Our aim is plotting the graph on sigma p and the expected returns. The standard deviation of the portfolio and the expected returns of the portfolio. But in that process, actually, we have two equations. Okay? But in between, actually, this guy is annoying, xc. So if I can eliminate xc, then actually I end up with sigma and r, which is very much the same as y equals to 2x plus 1. Okay? So in that process, what we do is the following. Look at what values xc is going to take. Xc belongs to these two values, obviously. Okay? That's our assumption. And you can always eliminate xc by writing xc in terms of sigma p and substitute that value in r, so that actually xc term will be eliminated. If you do that, this is the, hope you can see this. I can always write xc equals to rp bar minus 8 by 6. Okay. I just rearranged the terms in the second equation. If I can isolate xc, this is what you get on the other side. Then I can substitute this xc in this sigma p, so I end up with the following equation. 6 times rp bar minus 8 upon 6 minus 3 times 1 minus rp bar minus 8 upon 6. Okay. So finally I get rp bar equals to sigma p 2 plus 2. Hope you understand what I am trying to say here. Okay, we estimated the standard deviation of the portfolio and returns of the expected returns of the portfolio, but our aim is plotting the graph on this standard deviation and returns graph. So further, actually, we need to eliminate xc. Okay, then actually For each point that you select on this line between 0 and 1, you would find the corresponding point here, which is nothing but in terms of sigma p and RP bar. Did you understand the logic? So, yeah.
I think when you substitute the equation, that's plus 3 instead of minus 3.
Yeah. But my final answer is right because I copied it. My logic is wrong, but yeah. Because I copied from my own notes. Yes, that's the thing. Right. Okay. So basically, you're supposed to pick a point between 0 and 1, and by using this equation, okay, you can get the corresponding point on the two-dimensional graph. But remember that for each point, actually this equation is going to be changed. Okay? Because this equation is extracted under the assumption that we have, whatever it may be the point, so we eliminated xc totally, apologies. I am taking back the last sentence. Whatever it may be the value xc is going to take, the relation between the standard deviation and returns would be according to this equation. Okay? So now, here is the analogy. What is your investment strategy here? What do we mean by investment strategy? You have, let us say, £1 million and you want to come up with an investment strategy. In this case, investment strategy is nothing but how much money are you going to invest on first asset and how much money are you going to on second asset. Okay, that is what investment strategy is. So that means your strategy is nothing but choosing the x value, xc value, this point, okay? And the consequence of the investment strategy is reflected in terms of the standard deviation and the returns of the portfolio. This is what actually the area graph. Your investment strategy, how much money are you going to invest in first period, that is reflected, okay, onto the feasibility set. Here your feasibility set is basically, why should we look at the feasibility set? Because in our earlier case actually we always look at the consumption, first period consumption, second period consumption graph as feasibility set, because by looking at the feasibility set, you are in a position to say whether you like that particular consumption or not, whether that consumption would make you happy or not. Okay. Similarly, while investing, according to this strategy, you get a sort of standard deviation and return. And now ask yourself, whether this strategy is going to make me happy or not. What do we mean by make me happy or not? Look at the returns and the risk. Are you happy with the returns and the risk according to the point? If not, just move the xc value. That means change your strategy, nothing else. Am I clear? So can you link the initial toy problem and the complicated problem? That, well, okay, still we can complicate, but the idea is the same. Okay? So you can complicate the problem by just adding the more assets, nothing else. Nothing else. So this is basically one of the points. So this is a sort of straight line. Let us say S represents the standard deviation of asset S. That is, how much is that? 3. And standard deviation of asset C, 6. How do I know that? Because we assume 6 and 3. If you assume something else, actually those are something different. And the corresponding returns 8 from asset S and the corresponding return is 14. Okay. So if your portfolio is basically selecting only S, that means all your money kept on asset S, then actually the corresponding point on this graph sheet is that point. Make sense? And if you put all your money on the second asset, then actually you have the 6 here and 4, 6. So this is your 6. Okay. And whatever it may be the combination that you are going to consider, that must fall on this right here. Is it clear? So this is the case for, remember that this is the case for the row value, the correlation coefficient is +1. Okay? Any questions at this stage? I think the rest of the story would be very easy if you are comfortable with what I am saying to you. Is that clear? Shall I move on to the next one? No? Who said no?
Can you show the line for R1?
Sorry, can I?
Can you show the line for R1?
R bar?
Yeah. Is there any intersection between the two lines?
Well, see, this line is representing this one. The line, the straight line, that's what actually I mean. I hope actually you all, that's a good question actually. Hope you understand this. This line is representing this one. Because ultimately, whatever it may be combination, all those things are basically falling on the straight line. And obviously, this is the straight line. And again, there is one more point actually. I don't want to extend the straight line here or there. You know why? Because my assumption is xc plus xs equals to 1. If I extend, nothing wrong in actually extending this straight line, still that is valid, but actually that would violate the assumption that you have. Okay? But otherwise you can extend it. That's not an issue. Okay? Yeah, this line, this equation represents the straight line. Okay, so the next case is case 2. Rho equals to -1 point here. It's not 10, -1.
学过没有？我之前学过，
Okay.
他说的很累。
So the rest of the story is same. I'm trying to see actually which reason I am supposed to concentrate, on the sigma and the returns graph. So the next case is rho could be -1. If rho equals to -1, then what happens is you have the following. When you substitute rho equals to -1, you end up with the following: xc sigma c minus 1 minus xc sigma s whole square. I'm not writing all the stuff like this. You can write the same one and substitute minus. This is minus 2xc, and if you can write this as a plus b whole square, then obviously you end up with this one. Okay? And now, the same question you can ask yourself: what is sigma p? Sigma p square equals to this whole square. So then that could be xc sigma c minus 1 minus xc sigma s. or minus of xc sigma c minus 1 minus xc sigma s. The same argument. Only thing is you have minus here. Okay. Now, can I ignore the second one here? Why can't I ignore the second one in this case? Because there is no guarantee that this is always positive. There is no guarantee that this is always positive. Okay? If this is negative, then actually this is going to be positive. Okay? So you have two possibilities for the sigma. So that's why you just leave it both the things, equation 3 and equation 4 if you want. And again, we don't like this x value, xc value. So if we can eliminate the xc value by using the same one that we have extracted from our previous discussion in this particular case, is this one. When you substitute that, then what happens is the sigma p, the portfolio standard deviation, is going to be I am giving the simplified version. So if you substitute these things, you get it. Okay? Or sigma p equals to plus sorry, because we are looking for the relation between r and sigma. So, when rho equals to minus 1, when you look at the graph, you take the same one, sigma p, and you have one asset, standard deviation 3, other one is 6, and you have some other one 8 and 14. And this particular asset, if your portfolio involves only one stock, that is stock S. Otherwise, if your portfolio involves both, the other extreme, that is C. This point represents the standard deviation and the return. And now actually, when rho equals to minus 1, the feasibility set, the feasibility set would be these two straight lines. Okay? What is the slope of this straight line? 10 plus 2/3 sigma p. Positive or negative? This is positive, and this one, the slope is negative. Okay? So, there are two straight lines. One has positive slope, the other one has negative slope. And if you combine the previous graph, that is this one. If you remember the previous graph on your notes, that's basically connecting C and S. You get the straight line when rho equals to plus 1, and you get these two when rho equals to minus 1. So basically it would form the feasibility set. Any questions? That is another extreme case. So rho would take infinite values between -1 and +1. That doesn't mean the rest of the life we just keep plotting these graphs. Okay? Let us look at the variance of the portfolio. That is xc square. I'm just writing down this again. Sigma s square 2xc 1 minus xc. Sigma c, sigma s, and the rho value. Okay. Now ask yourself the following simple question. When for the given weights, for the given portfolio, when the sigma p square is going to be maximum?
Correlation is -1.
Is going to be negative. Okay. If correlation is negative, then
-1.
no, that's fine. No, my question is basically, when do you find the maximum possible sigma p square for the given xc values? If rho equals to +1, basically, anyway, these two terms are plus, first two terms. Okay? Sometimes this term might take negative or positive. So, and anyway, that depends on the rho value, because xc is always positive, 1 minus xc is also positive because of our assumption, and sigma c, sigma s also positive. So only deciding factor is rho. If rho is negative, then actually you are subtracting something from the first two terms. Okay? So maximum subtraction is possible when rho equals to -1. Is that clear? So when rho equals to -1, you get this one. When rho equals to +1, you get this right value. Now, if I substitute rho equals to 0.5, then the new feasibility set, this is feasibility set for rho equals to 1, and these two straight lines represents the feasibility set for the rho equals to -1. For rho equals to 0.5, do you think this set would be somewhere here? Here? This one? Somewhere. Okay, I don't know actually, but that would be somewhere inside, because the worst case is here. Okay, the best case is on the other side. You know that 0.5 is somewhere between worst and the best. So that means that must be somewhere in between. Now the next question is, in general, what is the shape of the feasibility set? Okay. There are many intermediate points. Rho equals to 0.5, rho equals to 0.001, but rho equals to 1 and rho equals to -1, basically very simple, because they create a sort of straight line kind of feasibility sets. But when you use rho equals to 0.5, let us see how the graph is going to look like. Any questions at this point? No? Are you following? Good. No, I would like to verify that I am clear or not. The next one, case 3, rho equals to 0. Rho equals to 0 is very simple, because you end up with only xc square sigma c square plus 1 minus xc whole square sigma s square, because the rest of the terms equivalent to 0, And we already know that for the given example, we live with this kind of portfolio. Okay. And when you substitute this, then you end up with the following: RP minus 8 whole square plus when you substitute, actually you get the answer. Again, sigma c square is 6 and sigma s square is very much same. Actually, I'm just giving the final answer. So when rho equals to 0, again I take the same graph sheet and I have 3 here and 6, 8 and 14 for these extreme events, that means extreme portfolios, that is S and C. Everything is same. When rho equals to 0, this is the relation between portfolio's variance and portfolio's return. How many of you think that this relationship can be expressed as straight line? In the previous case, when I substitute rho equals to -1, I get the following relation between RP and sigma p. Do you think this is a linear relationship? It is a linear relationship, looks like y equals to mx plus c. There is no square or square roots or cubes or nothing. So it's a linear one. But whereas when rho equals to 0, look at this, the relation between the variance, that is sigma or the standard deviation sigma p, and the returns of the portfolio involves square terms. That means they are no longer linear. So you cannot express the relation between the portfolio's standard deviation and portfolio's return by just using a simple straight line. Okay? You can plot this graph. I mean, in the previous two cases, we plot the relation when rho equals to -1. This is the relation. We plotted two straight lines. When rho equals to +1, we end up with only one straight line. That's why we plotted the SC line. And we also sensed that whatever it may be the rho value, the remaining values, that must be somewhere within this boundary. So that is what you are going to see there. This is a non-linear one. This is according to your anticipation. You suggested that for the remaining values of rho, the graph must be within those boundaries. Okay. So now this is for rho equals to +1. This one and this one, we identified that rho equals to -1, and this is basically rho is greater than -1 and less than 1. So you can imagine there are so many graphs, depends on the rho value. But you know that actually these values should not cross the boundaries. Those are set by rho equals to -1 and rho equals to +1. So now, if you are clear up to now, then we can conclude that now I know for the given portfolio or any sort of given set of assets, I can see the feasibility set on standard deviation and the returns graph sheet. So basically, all these points would represent feasible points. Okay? Any questions? No? Okay. Now, before discussing the remaining stuff, what I do is, I just quickly do one mathematical formulation for this final formulation for the day, don't worry. I would like to do analytically, instead of looking at the graph sheet, graphical picture, is there any way that actually I can a priori identify the minimum, the portfolio that would give us minimum variance? So let me explain this. I think you all are good at differentiation. That's what I found last week. So this time I'm not going to discuss any elementary things on derivatives. But it's a simple differentiation anyway. So let us look at any portfolio's variance. We are so used to the following formula. Remember that actually earlier we were using sigma p whole square. This time actually I'm taking square root and I just write sigma p. Okay, nothing else. So I need to find the square root for the sigma c square. 1 minus xc whole square sigma s square plus 2xc 1 minus xc sigma c sigma s rho cs. Just expand it. My aim is find the portfolio that gives minimum risk. You better remember this derivation, okay? Just note down. Better remember the derivation. In case if you do not understand, just try to practice as a homework. There are many homeworks. But knowledge is infinity actually, so I cannot give the infinity. I can only give partial knowledge. So remaining knowledge you should apply on your own. Actually, at this point, I take the opportunity and tell, since I mentioned about the knowledge. If totality of the, let us say that the knowledge is 100%, first quarter of the knowledge would come from your teachers. Second quarter of the knowledge comes from your colleagues, or the collaborators, or the classmates. The third quarter of the knowledge would come from the isolation. So that means you should develop your own perception. And the last quarter of the knowledge would come when you teach things to somebody else. I am in the process of filling my last quarter, so I am not complete. So you are not complete, so we should do our level best to reach the 100% knowledge. So that's why there are some homeworks. There is no substitute for that. Okay, so that's the philosophical thing. So we have the portfolio standard deviation, and we would like to find the minimum portfolio from the given x. What is portfolio? Portfolio is nothing but finding the xc value. When I fix my xc value, so that means how much weight I am going to give for stock C, that defines the portfolio. So I want to minimize the standard deviation by adjusting the xc value. Okay? So as you know, which is nothing but sigma p is depending on many things, but we are allowed to adjust only XC because that is what actually defining the portfolio. So you need to find dou sigma P by dou XC. It's basically I am finding the derivative of the standard deviation with respect to XC and equate that to 0. So that actually while solving that equation I get the actual value for the XC value. So first step is finding the, you can consider this as square root of x kind of thing. So you can write this as 2 square root of the same stuff. It's a bit tedious, but what I may do mistakes. Not deliberately, because it's lost half an hour, so I'm so tired. Okay, so 1 by 2 root x. So the idea is basically if you have y equals to square root of x, then dy by dx equals to 1 by 2 root x. So that is the form I am using. And I have something else I need to differentiate that separately. That is 2xc sigma c square plus 2 times 1 minus xc minus 1 sigma s square plus 2 1 minus xc sigma c sigma s rho cs plus minus 2xc sigma c sigma s rho cs. Okay, that is your numerator. And you need to divide, you need to equate this to 0. But don't worry, I'm not going to ask you to memorize, but remember the derivation, actually, that's very useful. And when I equate this to 0, I have the chance to find the xc value. In this case, that is sigma s square, sigma c, sigma s rho cs divided by sigma c square okay. This is the optimal portfolio weight. When you use these weights, then actually you get the variance. In case if this is rho cs, okay, underneath denominator. So this will give you the optimal portfolio where you can minimize the, or in case if this is the thing, I have very well written stuff. No, I'm just showing the best one. Yeah. This is very well written one. So. That is CS, okay? Sorry about it. But again, actually, I don't ask you to memorize the formula. Whenever you need, for example, if you are supposed to use this formula, either I give that to you or I will ask you to derive it. So, but I never ask you to memorize any formula because that's painful. Okay. Any questions? So we discussed various cases. Okay. have seen this, rho equals to -1, and we also discussed for the remaining values for rho that must live within the boundaries, those are set by rho equals to +1 and rho equals to -1. And for any arbitrary rho value, that could be rho equals to 0, we just discussed that is a nonlinear graph. I just mentioned that actually that is a nonlinear graph, but what is the guarantee that, well, we discussed this, but what is the guarantee that that nonlinear graph wouldn't be something like part C? Look at the part 1, we are comfortable with that graph, and we discarded this graph in our previous discussion because things won't go beyond the straight line, because that is going to increase the things. You can go up to the dotted line. From the remaining row values, actually you may decrease the standard deviation. So that's why we said this possibility is not there. But what about this one? Do you think actually this is a possibility? This is still nonlinear, the graph is nonlinear, and still that is on the other side of the boundary. How many of you say that this is the possibility? No? That means, how many of you don't think this is the possibility? Still actually I get only a few hands. So yeah, let me explain. So this is not the possibility, because the moment you consider any 2 points, U and V, you can always create a portfolio by using those 2 points. When you create a portfolio, the worst case would be the straight line that is connecting those 2 values, and the remaining points must be on the other side. Okay? That is the reason actually part C is not valid, so the only valid option is the first one. And here, have you heard about some of the definitions? Sorry. Few more minutes, don't worry. Convex and concave. Okay, this is convex graph, this is concave graph. How do I know that? Well, okay, just according to definition. According to the simple definition is, when you take any 2 points on the graph, and when you connect these 2 graphs with a straight line, okay, if all the points on the straight line are taking the lesser values than the values on the graph, so that means the straight line must fall below the graph, then we call that graph as concave. Okay. Whereas in the convex, any 2 points you connect with a straight line, all the points on the straight line are above the graph. If that is the case, that graph is known as convex. So when you come back to the portfolio graph that we just discussed, sigma p and RP, then you have 2 assets, and the graph is going to be something like this. Then the upper portion of the graph is, when you connect any of these 2 points here, that looks like concave. When you connect the points in the bottom part of the graph, that part looks like convex. So there is a sort of a point from where above you see concave graph, below that point you see convex graph, and this point is known as mean variance portfolio. The mathematical formula we just derived, the corresponding portfolio would represent that particular one. Okay, that's basically a sort of definition. And again, if M represents the mean variance value, the bottom one should behave like the convex one. That is not possible, and of course this is also not possible. The same argument we can use. I don't want to discuss the remaining complicated stuff. I think this would be enough for this week. So I wish actually I could cover the remaining so many slides, another 15 slides. But I think, by the way, sorry, don't leave. I don't want to. I have few tutorial questions.